Okay. So in this lesson, we're going to examine one final way to show that two triangles are congruent, and it specifically applies to right triangles. It specifically applies to right triangles. Okay. So it's called the hypotenuse leg theorem. It's called the hypotenuse leg theorem. And it actually is the booty theorem, because you have an angle and then two sides, an angle and two sides, but we don't call it that. We call it hypotenuse leg because it only works for right triangles. So the hypotenuse leg theorem says that if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another, then the two triangles are congruent. Well, why does that work? Here's the way you need to think about it. If there are two right triangles, what do we know about the angles? Two right triangles, that means that they both have two 90-degree angles, which means that they have two congruent angles. So really it's some form of angle, side angle, or some form of angle, side angle, side, or something. Like it's some kind of form of that, right? So it's not too far-fetched to figure out why it works. So we're going to look at the proof because it's a theorem, and technically if we want to use a theorem, we have to prove it. So in this diagram below, triangle ABC and triangle CBD are given such that, can you guys hold the cap? Thank you. Such that segment BA, so I want everyone to mark that. Mark segment BA. I just put a new battery in here. It's like every day I have to change the batteries. Such that segment BA is congruent to BC. So everybody mark that on their paper. You're also told that segment BD is perpendicular to segment AC. So what does that mean? How do they cross? What do they do when they cross? What do perpendicular lines make? Yeah. So they make this, right? But can we think just for a second? If angle BDC, that's what I drew that as. If angle BDC is 90 degrees, what is angle BDA? Because it forms a linear pair, right? And I mean, like, okay, so I'll just leave it like that. So I have two right angles right here. What do I know about segment BD? What do I know about segment BD? What's it congruent to? It's congruent to itself. Yeah, segment BD is congruent to itself by the what property? Reflexive property. So here's what I have. I have this triangle in yellow congruent to this triangle in blue. Because they're both right triangles, we have their hypotenuse and one of the legs. Can anybody tell me why that has to be true? Why is it that if the hypotenuse and one of the legs are congruent, the other legs have to be congruent? What theorem do we use to find the missing side of a right triangle? Let me say it again. If you know the side measurements of a right triangle and you want to find one of the missing sides, what theorem did you start using in 7th grade and 8th grade and used it in Math 1? What theorem lets you find the missing measures of a right triangle? The Pythagorean theorem. Who said that? Good job, Charlie. Yeah, it's the Pythagorean theorem. So that's why this works. This is a form of, we kind of secretly use Pythagorean theorem, right, to make this happen. So let's just explain how we know this works. Mark what is given. So here's what I marked. I marked that segment AB. Oh my God. I'm using some fat like stylus, so I have to change the size of the pen. Sorry. So I'm using that AB. Oh my gosh. I'm using that. I love technology. I'm using that segment A, B. I'm telling you what is congruent or equal to CB. We know that, right? We know that those two things are congruent to each other. We also know that because of the perpendicular lines, we have right angles. Right angles from the perpendiculars. Okay, isn't that what we marked? The right angles from the perpendicular. And then the last thing that we know is that BD is congruent to itself by the reflexive property. Those are all the things that we marked. Okay. So the second question says, well, what two sides of the right triangle are marked? Well, we marked the hypotenuse, congruent to a hypotenuse, and we marked a leg congruent to a leg. So because we have right triangles, that's kind of like the proof of the hypotenuse leg. So these two triangles are congruent. Are there any other angles in the two triangles that are equal? We know that these two angles are congruent to each other, and we know that triangle ABD is congruent to triangle CBD by hypotenuse leg. We know that because we just said like that works. What other angles though are congruent? Well, what about this angle? Is this angle congruent to this angle? Yeah. If those triangles are congruent to each other, then angle A has to be congruent to angle C. And I'm going to number this one up top because God forbid I have to write a lot of letters. And angle 1 has to be congruent to angle 2. Why is that? What theorem did you guys learn the other day? It was actually a definition of congruent triangles. If triangles are congruent, then the corresponding parts of congruent triangles are congruent. What is that? The corresponding parts of congruent triangles are congruent. So that also means that segment AD is congruent to segment CD. So what other theorems could we use to justify this? Because we don't have to use hypotenuse leg. We could also use side, side, side. We could use side, angle, side. We could use angle, side, angle. And angle, angle, side. Okay, you can use all of the theorems when you have right triangles, but hypotenuse leg is the quickest. It is the quickest. It's going to get a little gamey without a working pen. So let's go down to triangle number 2. And I want to tell you that like this is the makings of a proof. What we're doing right now is like the makings of a proof. And then all we're going to do is just a bunch of proofs. We're just going to keep practicing it. So anytime you're given a statement, you should mark it on your drawing. Anytime you're given a statement, you should mark it on your drawing. So you're told that segment CD, which is right here, is congruent to segment BD. So I would mark that. Put that on your drawing. And I know, Chandler, you want it nice and big, but it's really hard to get the picture and all the words in. So if you need to move up, do that. I'm doing my best, okay? You're also told that segment CD is congruent to segment A, or not congruent, it's perpendicular. So what do we know about perpendicular lines? When they intersect each other, they make what? They make right angles. So if segment CD, if this segment is perpendicular to this segment, then I have a right angle right here. I draw it. And if segment BD is perpendicular to segment AB, then I also have a right angle right here. So draw that in there so you can see exactly what you have before you even try to figure out how to prove that those two triangles are congruent. Okay. So the first question says, what can we use to say that those two triangles are just right triangles? Because I can't use the hypotenuse leg unless I state that I have right triangles. So what of the given statements lets me know that I have two right triangles? So this is my given statements right here. Of the things that were given to me, what two pieces of information tells me that I have a right triangle? The fact that CD is perpendicular to AC and that BD is perpendicular to AB means you have right angles. Okay? True or false? True. If you have a triangle with a right angle, then the triangle is what? If you have a right angle inside of your triangle, then what kind of a triangle is that? Then the triangle is a right triangle. So you can say, well, because I have perpendicular lines, I have right angles. And because I have right angles, I have right triangles. So you need two statements to kind of prove that you have a right triangle. That's what it's trying to get you to say. First, you got to say that you have two right angles because you're perpendicular lines. Then you got to say that you have two right triangles because your angles contain, like the triangle angles are like. So what other piece that's not marked in there do we know is congruent? What other piece in there that we didn't mark do we know is congruent and why? So AD, we have to mark it first. We know that segment AD is congruent to itself. And I heard someone say the reflexive. So I'm going to mark it. AD is congruent to AD by the reflexive property. Okay. AD is congruent to AD by the reflexive property. So do we have enough information to use the hypotenuse leg theorem? Well, let's see. Do we have two right triangles? That's what we have to have first. Yes or no? Okay. Number two, do we have two congruent legs? One leg of one right triangle congruent to one leg of the other? Yep. And number three, do you have two congruent hypotenuse? I'm just going to call it hypots. Yes or no? Yeah, that's that AD, right? So we have all the information that we need to say that triangle ABD is congruent to triangle ACD. So I'm going to say that. I'm going to say triangle A, God bless you, BD is congruent to triangle ACD by HL. That's how we abbreviate hypotenuse leg. Congruent by HL because we have all of the information that we need. So I'm just gonna I think that the only way you get good at doing proofs is to just do them. And then you'll recognize that there's a system, right? So we are just going to jump right into doing proofs. So everybody turn to page 35. And I'm going to introduce you to two column proofs. I feel like I'm missing something. I'm missing a whole page maybe. I am missing a whole page. Huh? No, we have to do it. I just don't know why it's not in here. I mean, I do. It's this thing right here, but where did it go? No, I just need to move this out of the way. There we go. Okay. All right. So that's our first example. So all of these are going to be 2-column proofs. All of the proofs that we do today are going to be 2-column proofs. Okay. So that's kind of like the standard form to do proofs. So your proof is always going to have a statement. You need to write this down. And a reason. Okay. And we're going to just make 2 columns, statements and reasons. Statements and reasons. Whenever you use a statement that's given to you, your reason for using it is called given. So the first thing that I'm going to write down is I'm going to group these 2 perpendicular, this statement about perpendiculars. So we number all of our statements and our reasons so that they match. So number 1, RS is perpendicular to TS, and RV is perpendicular to TV. Why can we say that? Well, because it's given. That's why we can say that. It's given to us. It's given to us at the beginning of the proof. So once I see that I have perpendicular lines, I'm going to go ahead and do this. I'm going to draw a little right angle where where RS and TS meet. And I'm also going to draw the right angle where TV and RV meet. And that's going to be my next statement because I drew something and I want to talk about it, right? So the next thing that I'm going to say is that I know that angle S and angle V are right angles. Why am I able to say that? Why did I draw angle S and angle V as right angles? What led me to draw that? What gave me the permission to do that? Yeah. Well, we know that the first statement that we said was RS is perpendicular to ST. So if RS is perpendicular to ST, that means they form a right angle. Right there where those 2 lines meet, right? And if RV is perpendicular to TV, they form a right angle. What are the names of those 2 right angles? Angle S and angle V. They're right angles because, so here's our reason, perpendicular lines, and use the abbreviations or the symbols. Perpendicular lines make right angles. That's all you need to say. Okay? Perpendicular lines make right angles. Okay. So if I have 2 right angles, then what kind of triangles do I have? I have 2 right triangles. So that's the next thing I'm going to say. The next thing that I'm going to say is that triangle RST and triangle RVT are right triangles. Why can I say that? What makes a right triangle? What's the definition of a right triangle?
A right triangle is a 90-degree angle.
A right triangle is a triangle with a what?
A 90-degree angle.
Do we have 90-degree angles there? Don't we have 2 right angles?
Yes.
So those are right triangles by definition of
a 90-degree angle.
Of a
degree of right way.
Definition.
The definition of right triangle.
Yes, it's just the definition of a right triangle. That's why I can say that. It's just the definition of a right triangle. I'm going to highlight these two statements right here because there's something really important about this. Anytime you want to use the hypotenuse leg theorem, anytime that you want to use the hypotenuse leg theorem, you have to, first of all, say that you have a right triangle. Otherwise, you can't use it. Even if you have perpendicular lines that create right angles, then you have to say that the triangles are right triangles. Okay? Hypotenuse leg theorem says if you have right triangles, it's not enough to just have right angles. So those two statements should always go together. Always make them go together. Does that make sense? That's why I highlighted them. Put a little bubble grouping around it or something. They want to go together. Okay, so now I have right triangles, and I'm going to go to my next given statement, number 4, and I'm going to put this in here because I still haven't talked about that. So statement number 4, I'm going to say that segment ST is congruent to segment VT. And why am I able to say that? Well, because it's a given. It's a given statement. Okay. And then I'm going to mark it. ST is congruent to VT. I'm going to mark it on my picture. Still trying to prove these two triangles are congruent. Say it.
The middle line.
The middle line, yeah. Segment RT. That's the next thing I'm going to say. Segment RT is congruent to itself by what? What lets me say that? What property is that? That I can say something is congruent to itself? Reflexive property. Reflex prop. So now I'm going to mark it. I'm going to mark that on my triangle. So here's my first triangle. Triangle RST looks like this. And triangle RVT looks like this. Do I have enough information to say that those two triangles are congruent by hypotenuse leg? Yes, I've said they're right triangles. Yes, their hypotenuses are congruent to each other. I do. Yeah. Are my hypotenuses congruent to each other? Yeah, that's RT, right? Do I have a pair of legs congruent to each other? Yeah, that's STVT. So we're done. We just have to say that they're congruent. So in the prove statement up here, what we're trying to prove is that triangle RST is congruent to triangle RVT. So we just want to say that. We're like, that's our last step. Triangle RST is congruent to triangle RVT. Why can we say that? Well, by hypotenuse leg, by HL. Questions on that? Does that make sense, the way that flows? Okay, let's try it again. So every time I do a proof, I try to do it a little bit differently each time just so I become more familiar with it. But every time we do a proof, we're going to have our statements. Every single time, you're going to have statements and reasons. That doesn't go away. Okay? Every single time, statements and reasons. I never, ever, ever write all of my givens at one time. I try to write them so that I can write something about them once I write them. If I smush them all in together, then I get lost. I forget to say something. So I'm going to start with this and explain to you what that means, and this, and I'm going to put it all together at once. So this segment bar A and B, that's just trying to tell you that A and B makes a straight line. That's all it's trying to tell you. It's a segment, it's a straight line. So you can assume that it's a straight line. That's what it wants you to know. There's no angle taking place in there that you don't see. It looks like a straight line, and it is. That's what that first statement is telling you. So I'm just going to write that A and B with a bar over it. But I'm also going to write that segment CM is congruent to segment DM. And then I'm going to mark them. CM is congruent to DM. And I'm going to say that it is given. That was a given statement. Okay. So I can't really say anything about that. Like there's nothing that I can derive from those two hypotenuses being congruent. I don't even know if they're hypotenuses yet. So I have to go to my next set of givens, which is this right here. So I'm going to say next that CA is perpendicular to AB and that DB is perpendicular to AB. And that is also a given. Now, sometimes you're going to see proofs and they smush all of the givens at one time. I just don't believe that that's a good practice because it's just not. So segment CA is congruent to AM. So I'm putting what over there? What am I going to draw at CA and AM where they meet? I'm going to draw a right angle. And segment DB is congruent or is perpendicular to segment AB. So I'm going to draw a right angle over there as well. So what do you think I should say next? Think about what we did up top. Once that they're what? I can't say that they're right triangles until I say that I have right angles. So let's say that. What two angles do we have that are now right because of the perpendicular lines? Angle what? Angle A and angle B. Angle A and angle B are right angles. Why am I able to say that? What makes right angles? That's perpendicular lines. Perpendicular lines make right angles. Very good. Perpendicular lines make right angles. That's what we want to say first. That says make. Sorry, I know that looks really crappy, but it's big fat stylus. Perpendicular lines make right angles. So now I have two right angles in each one of my triangles. So now what can I say about my triangles? That they're right triangles. So I'm going to name it just like it's named in the statement up here. So triangle CAM and triangle DBM are right triangles. So I went from using the angle symbol to the triangle symbol. Why can I say that those are right triangles? Yeah, good job. Definition of right triangles. Okay, so now I have two right triangles, and now when I look at my picture, I can see that I have one hypotenuse congruent to another and two right triangles. So I'm doing pretty good. I need to go back up to the top and look at my last given statement. I need to go look at my last given statement, which is that M is the midpoint of segment AB. I need to say that. I need to say that next. M is the midpoint of AB. And that is given. I'm going to say that because it's given to me. We need to talk about what that lets us. What do we know about a midpoint? We talked about midpoints in this chapter. On like page 7 and 8 in this whole unit, we talked about midpoints. What do midpoints let us say? What does a midpoint do? If I were to take this piece of notebook paper right here, and I were to fold it in half, This is the midpoint right here. This is the middle of the paper. It's the midpoint. But when I find the midpoint, what have I essentially created? Two what?
Two sun. Oh, wait.
Two pieces. What can you say about them?
They're the same.
Two pieces that are the same. What do we call those?
Identical.
What do we use? What do we call them mathematically?
Or wait, what? Wait, what are we looking at?
Say it again. Yeah. So if M is the midpoint, sorry, hold it back. If M is the midpoint of segment AB, what does that mean AM and BM are to each other?
They're ruined.
Let's say that. Let's say that. Let's say that. Let's say that.
Yes.
So if M is the midpoint, then segment AM is congruent to segment BM. Why can I say that? Well, that's just the definition of a midpoint. There's actually this like fabulous midpoint theorem, but you can just use definition of midpoint. Okay, so I've just said that those two segments are congruent to each other, so I need to mark it so I can actually kind of see what's going on. So do I have two right triangles? Yes. Do I have one hypotenuse congruent to another? Yes. Do I have one leg congruent to another? Yes. So that means that the two triangles are what? Let's say it. Statement number 7. Triangle CAM is congruent to triangle DBM. Why can I say that?
Because it's HL.
By HL. Good job. What's that stand for? Hypotenuse leg. You guys are awesome. Okay. Are we doing okay? We hanging in there? No quali? Is your head spinning? Okay. Here's what I think, quali. I think that the more you practice it, the better you are. And if at least we go through them together and you have 6 or 10 really good worked out proofs, you have something to look back at. Okay? Okay. All right. So we're going to do some more 2-column proofs. Okay? That's what it says. Hey, guess what? We're doing more 2-column proofs. We're just going to keep doing them. No, we're not done. We're just going to keep on going. So statement, and you can abbreviate it if you want, and reasons. Okay. I know it says how many rows are up top, but I haven't yet to solve a proof that has the same number of rows as whoever wrote this paper does. Okay. So number 1, Jacob, pay attention to what we're doing. Number 1, we always start with one of our given statements, and we only have one given statement. The given statement says that C is the midpoint, and I abbreviate as much as possible, of BD and AE. I'm going to say that because it is given. Well, what does a midpoint do? We did just talk about it.
The midpoint is the middle of the graph of the thing.
So if C is the midpoint of BD, what does that make? C is the midpoint of this segment right here. What does that make? So I want everyone to look at the board. I highlighted this segment, and C is the midpoint of it. So what does that do? So if C is the middle of that, what is happening to segment? What is C creating? It's creating two congruent pieces. What are they? No. What are the two congruent pieces that BC just create, or that point C just created? Yeah. BC and DC are congruent to each other. right? Because if C is the middle, then this piece is congruent to that piece. That's just a definition of midpoint. But it also says that C is the midpoint of AE. It also says that C is the midpoint of AE. So what does that mean? What else is congruent? Yeah. Then AC is congruent to EC. And both of those are by the definition of midpoint. That's what a midpoint does. It makes two congruent pieces. That's it. So I'm going to mark that. And then, Quali, you said something before when I wasn't even asking about it, but it jumped to you. It jumped right off the page. It began with the word V. What did you say? Yep. That's not what I thought you said. You said vertical what? Vertical lines. Okay. Well, what do you guys see up there? If I'm trying to prove that two triangles are congruent to each other, what kind of things do you see up there other than the two congruent segments? Say it. I have vertical angles. Oh my gosh. That's what I thought you said, Quali. I have vertical angles right here. Right? Do you guys see that? So let's name those. Let's see. That's angle ACB, and it's going to be congruent to angle ECB. Why can I say that those two angles are congruent? 8 and T. Why can I say those two angles are congruent? Because they're what kind of angles? Yeah, because they're vertical angles. And what do we say all the time? I say every time we use vertical angles, what did I say to you? Because vertical angles are always what? They're always congruent. It doesn't matter what the setting is, vertical angles are congruent. So just write that. Vertical angles are congruent. We know that. We know vertical angles are congruent. It's just a law of math, okay? Pick your head up, Mylena. It'll go faster if you pick your head up and you're engaged. Okay, so now I want you to look at those two triangles. Have you learned a theorem this whole week? This is not a hypotenuse leg. There's no right angles. Have you learned a theorem at all this week that would let you say one triangle is congruent to the other by what you have marked there? What? What's marked up there? Aiden, you're rocking this out. Side angle, side. So name the triangles the same way that you just named your angles. Triangle ACB is congruent to triangle it's ECD. I'm so sorry. ECD. I see that now. I got to fix that. If I can erase it. I have a big fat pen, so I might erase more than just what I need. And why is this? What did you say that was? What was your reasoning, Aiden? Yeah, a little bit of sass. Side angle, side. Let's look at that. So I have side, angle, side on triangle D or on triangle ECD. And then I also have side, angle, side on ACB. Look at that. Okay. Questions? Let's go to the next one. What do we have to start with? Yeah. STMT RSN. Okay. Statement number one. What does statement number one say? Well, it says that AB is congruent to CB. That is our given. And then I'm going to mark it. AB is congruent to CB. What the heck does that next statement mean? I don't even understand that. BD is the median of AC. Say that again. It's the midpoint. That's the definition of median, right? So let's say that. BD is the median of AC. And we're going to say that because it's given. But if it's the median, then what that means is this point right here is the midpoint. So I'm going to say that D is the midpoint of AC. And why am I going to say that? That's just the definition of the median. When did we learn that? Well, we talked about midpoints and a median, page 7 and page 8. And then we created mid segments, right? Well, D is the midpoint of AC. So what does that create? What does D do to segment AC? Cuts it into what? Cuts it into 2 halves. How do I say that I have 2 equal pieces? But what 2 pieces are congruent? Yeah, segment AD and is congruent to segment DC. Yeah, sure. And why is that? It's the definition of a midpoint. Yeah. So now I'm going to mark that. You guys are killing this. Okay. Quali, I'm coming to you. You got this, Quali. Quali, I want you to look at this right here. What can you say about segment BD? It's congruent to itself. Why? Why is BD congruent to BD? Let Quali think about it. I gave away some bonus points for that this morning. We've used it a couple of times. It begins with the letter R. It's a property. R reflexive. The reflexive property. Remember yesterday I said think of it like your reflection. When you look in the mirror, you see yourself, it reflects, right? So it's a reflexive property. So now look at what you have. You have this pink triangle right here compared to this blue triangle right here. And we just said that this middle piece is congruent to itself. So can I say that triangle ABD is congruent to triangle CBD? By what theorem or postulate that we use this week? What do I have marked on those triangles? Say it again. Did I have a single right angle on there? No. What do I have marked on those triangles? All the what? All the sides. So what theorem did we learn that just has only sides in it? Side, side, side. Yeah, that's what it sounded like. It sounded like you went hypotenuse leg. I mean side, side, side. Yeah, I heard that. So these next 2 are really short. Okay. So 4 rows or less. Aiden, run really quick. Give me your notes so I can fill those out as we do this. Because you waited for more than an hour, and I appreciate that. Quickly, here's your pass. Okay, here we go. So let's look at this one. We're gonna prove that triangle ABC is congruent to triangle DEF. I'm on the next page. I don't know. Flip it. Page 37, I think. So I have a statement and I have a reason. So let's talk about my given. Statement number 1. Statement number 1 says that AB is congruent to DE. Given. It's already marked for us. Statement number 2 says that segment BC is congruent to EF. That's also a given. Statement number 3 says that angle B is congruent to angle E. That is also a given. So, do we have enough information to say that those 2 triangles are congruent to each other? By what? What's marked congruent on the triangles? SAS, side angle side. Good job. So triangle ABC is congruent to triangle DEF by SAS. Yeah, that one was not hard at all. Not hard at all. That was not really difficult. Can I change something? I'm sorry, I'm going back to it, Kara. I'm sorry. So for the next one, number 4, at the bottom of number 4, where it says prove triangle PQR is congruent to triangle TUS, cross that out. We're not proving that. Cross that out at the bottom. Instead, we're going to prove that segment PR is congruent to segment TS. Kara, are you done with that? Okay. So I'm going to cross this out. And instead, we are going to prove, oops, maybe I'm going to cross it out. Instead, we're going to prove that segment PR is congruent to segment TS. So let's start with what we know. We have some statements and some reasons. Draw your 2 columns. Draw your 2 columns. Okay. What do you want to start with first? Jose, there are some filled out notes up front. Maybe not. What do we know? What's the first thing we want to say? Yep. We're still filling them out, but you can have that. What's the first thing we should say? Go to one of your givens. What? Where are you coming from, Jose? Who signed this? Who is it? Oh, Aida. Okay. So the first thing I'm going to say is that segment PQ is congruent to segment TU. Given. And it's already marked for us. Do you guys see that? PQ is congruent to TU. The next thing that I'm going to say is that angle P is congruent to angle T. That is also given. The next thing that I'm going to say is angle Q is congruent to angle U. Given. How in the heck am I going to show that those 2 segments are congruent to each other? So I have a question, okay? I have a question. If the 2 triangles were congruent to each other, would then the 2 segments be congruent to each other? Listen to what I'm saying. If I could prove that the 2 triangles were congruent to each other, if I could prove that this triangle was congruent to this triangle, then wouldn't the segments be congruent to each other? Because that's the definition of congruent triangles. What is the definition of congruent triangles? We just used it at the beginning of our notes. I wrote it for you guys on page 34. What did I say? Do you guys remember? What lets us prove something? If we know that the 2 triangles are congruent, what lets us say that all the other parts of them are congruent? Corresponding parts of congruent triangles are congruent. So can we prove that these triangles are congruent first? How? What theorem? Aiden, stop. Angle side angle. Yeah. Triangle, not you. Other Aiden. So triangle, you're like going to break your arm. PQR is congruent. So here's how I named this. 1 angle, side, 2 angle markings. Do you see that? So I have to name the other one the same way. TUS. And you guys told me it was angle side angle. Well, then statement number 5 can be that PR is congruent to TS by CPCTC. I wanted you to see a proof like that. I wanted you to see a proof like that. Do you need to use the restroom? Is that what you're asking? Yeah, come here. Okay. All right. So this is your work on, and you guys can work on this together, but really, I really have a purple worksheet for you, which is what I want you to do. So I want to maybe spend a couple minutes just talking through this, and then I'll pass out your purple worksheet. Jack H. No, I really thought that we could get farther than what we are. 17. So let's look at number 1. Can we just look at a couple of these together, and then I'll get you guys started on your authentic homework. And maybe this is just maybe what you should do. I don't know. How much time do we have? Okay. All right. Here's what I'm going to do. I'm just going to let you guys work on this. These are almost all the way done. Do you guys see this? These proofs are almost all the way done. You don't have more than 3 or 4 blanks to fill in each one of them. Some of them you're filling in a statement. Some of them you're filling in a reason. So if you look at the first one, for example, yeah, we'll just make this be your homework. I'll do the purple sheet tomorrow. So if you look at the first one, you have AB is congruent to DE. That's already written there as your given. So what else are you missing? What else are you missing? Well, your next given is what? Yeah, so that's what's going to go there. And then your last given, well, that's right here. So the statement that you're missing is just the word given. I mean, this is not hard. Okay, you're going to be done with this in no time. If you had to pick a number, 6, 7, 9, or 10, what would you pick?
10.
6, 7, 9, or 10. How many of you want number 6? 2 tally marks. How many of you want to do number 7? 4 tally marks. How many of you want to do number 9? That's 3 tally marks. How many of you want to do number 10? Okay, 1, 2, 3. So number 10. Here's what I'm going to do. I'm going to give you this. We'll go through these tomorrow because I want you to, when you take your test next, I want to say it's going to be on Thursday. I want you to use this sheet. I'm going to let you use this sheet. Your test isn't tomorrow. Your test isn't until next week. I get the confusion. It's next Wednesday or Thursday. I can't remember. However, I want you to use this sheet because you have some proofs on there, and they're not these, but these are a really good compilation of all of the things that you're going to see. And so I feel like if you have something to look at, you're better. Does that make sense? Like you have some examples. So I want everyone to do number 10 for tonight. Do number 10. You'll be fine. Try number 10. And then we'll do the rest of these in the next couple of days. So that way, by the time it comes to your test, like we pick 2 every day to do as a warm-up or 1 every day we'll do 1 every day as a warm-up. That way, by the time it comes to your test, you have these all filled out. No, you're doing everything on that worksheet, and you're doing number 10 from your purple sheet. Yes. Here, look, trade me out. You pass those out. 34. Did I give you the filled out notes? Oh, yeah. So this, yes, you're good. Yeah, give me a second. Well, hang on. You guys are like making my brain hurt. I'll make a video.
So it's just this paper and then the number 10 on that paper.